Good day, viewers. Let's get to solve this question very quickly. The question says that 50 cm cube of the gas was collected over water at 10 degrees Celsius and 765 millimeter mercury. So it means that the volume of water collected at 10 degrees Celsius and 765 millimeter mercury is what? 50 cm cube. Cm cube. So we record that as our V1. Please take note. Now, aside that, we are also giving the temperature in which the 50 centimeter cube of the gas was collected. So the temperature given to us here, which is T1, is 10 degrees Celsius, which was converted to Kelvin. So that's plus 273 Kelvin. So that will give us 283 Kelvin, right? So now the next thing given to us from the question is this, the pressure. Now, we cannot get to solve the pressure until we are done, because if we note, we are given two pressure. We have the total pressure as 765, and we are also having our saturated pressure as 5 millimeter mercury. So it means that we have to subtract the total pressure from the saturated pressure. Please take note. So if I have to do that now, that will be given as vapor pressure. Vapor pressure is equals to total pressure minus, which is going to be minus the saturated pressure. Minus the saturated pressure. Saturated pressure. So if I have to do that now, what is the total pressure given to us from the question? It's given to us as 765 minus the saturated pressure is given to us as 5. So that gives us 760 mmHg. So it means that the P2 now, P1 rather, P1 will be recorded as 760 mmHg. Please take note. Now, another thing now that we are doing from this one, what we need to look for is P2. What is P2 saying? P2 here now, remember I say that our standard temperature and pressure, and the standard pressure is 760 millimeter mercury. So which means that P2 here happens to be 760 mmHg. Now what's the standard temperature going to be? The standard temperature in Kelvin, which is going to be T2, is given as 273 Kelvin. So now, for us to solve this question, there is only for us to apply our general gas equation formula, which is P1V1 all over T1 is equals to P2V2 all over T2. Now remember, what we are looking for is the second volume, because the first volume is given as, or the first volume of the gas is given to us as 50 centimeter cube. So if I have to do that now, that will be V2 here now is equals to P1V1 C2, right? All over T1 P2. So now let's get to solve. P1 from the question is given as 760. Remember, that's after we must have subtracted the total pressure from the saturated vapor pressure. So multiply by what is the V1 given to us from the question. The V1 given to us from the question is 50. So that's times 50. Then times what is our T2? Remember, standard temperature and pressure. So the T2 given to us, or from the parameter, which is standard STP, is given as 273 Kelvin all over. So what is the T1? The first temperature given to us, okay, that's this here, T1. So we have to convert it because it is given to us here in Celsius. So there is a need for us to convert the temperature scale to Kelvin, which is 283. So that's 283 multiplied by what is the P2 given to us, which is 760. So now let's do our calculator. That's 760 multiplied by 50 multiplied by 273. That will give us 10 million, wow, 374,000 all over. Remember, what we are looking for is what? Is V2, right? So all over 283 multiplied by 760. So that's 215,080. Now remember, we could have also used this and this to cancel out, depending on if it is something probably you just need to solve very fast to get your answer. So now V2 here now, which is what? 10,374,000, right? Divided by 215,080. So it means that V2 is giving our answer, which for V2 is 48 centimeter cube. We need to watch out for parameters like this, or things like saturated vapor. Now, when you are still saturated vapor, there is need for you to subtract it, because you have to subtract your total pressure given from the saturated pressure. And remember, STP has been given, so you have no problem. All you have to do is take the constants, which is 760 milliliter mercury, then use it as your P2 or as your second pressure. So do well to subscribe and like my page.